When hiking in the desert, a rain shower can be a beautiful experience. However, water flowing down a trail is quite another matter. In this video, we'll explore how to protect trails from the erosive power of water in several situations.
Normal trail traffic loosens the dry soils and small rocks of arid land trails. Both trail traffic and runoff from rain events push the lighter materials down the trail. If water is not removed from the trail, the resulting erosion will leave annoying large rock and cut more deeply into the trail.
The often brief but intensive rains during the summer in particular can rapidly convert a trail on erosive soil into a gully that captures water.
Trails that rise and fall, like this one, are the least likely to erode because there's frequent opportunities for water to leave the trail.
We're standing at a point which is called a grade reversal because the trail gradient or slope comes down in this direction, reverses, and then climbs back up.
This forces water to leave the trail here at the grade reversal. Let's see why that's important. When rain falls on slopes like these, the water flows downhill in a sheet flow. As trail builders, we have to figure out how to build a trail into that slope and keep the water flowing downhill in a sheet. This yellow rope demonstrates what we want to do. We want the water to flow across the trail in the sheet flow and then down the lower side as a sheet as well. That way there's not a lot of erosion. Unfortunately, in arid lands, this ideal doesn't last for very long. Notice how the yellow rope dips as it crosses over the trail. In the center, where it's the lowest, is where most of the concentration of use occurs. This is a normal wear pattern. The soil that's dislocated by tires, hooves, and feet moves down trail by gravity and water. After this cupping out occurs, water's not going to sheet off the edge of the trail, it's going to actually flow right down the trail. So what we have is a situation where water is coming onto the trail in a sheet, it hits this cupped out trail, is flowing downhill, and it's going to leave at its first opportunity, which in this case is our grade reversal. The longer the water's on the trail, the more speed it's going to pick up and the more erosion it's going to cause. Trails with frequent grade reversals will limit the damage runoff from rainfall can do. Opportunities to introduce grade reversals occur naturally at stream and wash crossings, draws, and small dry gullies. They can be laid out during the design of new trail or introduced to existing trail.
Wash crossings are common on desert trails. As you can see, the approach to this crossing adheres to normal standards for trail grade. There's no radical plunge into the crossing. Whenever possible, don't do anything once you've reached the bottom of the wash. In this situation, the natural crossing was unpleasant to walk on, and we were able to find plenty of large rocks to create a nice, durable surface. Volunteers who built this structure saw that there was a large watershed feeding into this wash, which meant that they needed a nice, durable surface, which is exactly what they built. Notice that the large paving stones interlock. This gives the added ability to resist any dislocation during a major flow event. In addition, substantial rubble was added just downstream of the surface to prevent any water flow from scouring out the wash and undermining the pavers. On a final note, this structure preserves the natural profile of the wash. Any structure that would narrow the profile of the wash could just get wiped away.
This is an unplanned trail into a drainage crossing. It's steep, difficult to walk on, and unsafe. It really plunges down into the drainage. The alternative path I'm walking now follows the correct trail grade standards, is safer, and more easily drained. You can see that it's on the same hillside, only it's a better alternative to the steep one we had over here.
We have talked a little bit about trail design in this video. Long-lasting solutions to get water off of trails is through good trail layout. This is why very steep trails can rarely be improved upon without inordinate amounts of hardening. The more practical long-term solution is usually realignment with plenty of grade reversals built in. Grade reversals can sometimes be added to moderately degraded trail, and a well-constructed wash crossing can become a point of interest rather than a dreaded encounter. Finally, short sections of unavoidable steep trail can be hardened through methods such as stone pitching.
Sometimes you have no choice but to accept that water cannot be kept off of a short section of trail. In such circumstances, it may be worth the effort to harden the tread surface. This is the situation VOAZ faced here, where water during rain events could not be kept off this heavily used trail. Realignment to a gentler grade was not feasible. One solution could have been steps, but suitable rock for 40 feet of steps was not available, and trail users do not like steps. The type of paving you see here is called stone pitching. Materials for this type of tread hardening were available nearby. The first task was to set some heavy rocks on the outside edges and across the tread area every 4 or 5 feet to hold the pitched rocks in place. Then pitching rocks were placed inside the stone boxes, keeping the top face of each stone close to level to form the tread surface. Even smaller rocks like these can be used as long as their longer dimension is perpendicular to the tread surface. This provides load-bearing capacity, lateral stability, and good traction for trail users. Here, a rock edging box is almost filled with stone. The last step is to slowly sweep in fines or sand to fill the gaps between the stones. Sweep off excess fines and you have a very comfortable, stable, and water-resistant length of tread.